1.1 notes has 2 pages that you're going to cut in half. And that means 4 half pages you're taping in. A quadratic function is a function that can be written in standard form. And standard form is y equals ax squared plus bx plus c. A can't be 0. If a was 0, 0 times x squared would go away and it'd be left with x. That would be a linear function. So standard form is y equals ax squared plus bx plus c. The graph of a quadratic function is called a parabola, which you guys had a lab to deal with on the graphing calculator. All right, some more definitions that you had in your cutout parabola. We have the axis of symmetry. And the axis of symmetry is about a line that I can draw that cuts that parabola right in half. We always do it as a dotted line. Writing equations of those vertical lines, which again we did in linear functions. X equals some number would be an equation of a vertical line. And AOS, we like to say, instead of keep saying axis of symmetry, we do just abbreviate and say AOS. That was one of the things that you had to label in your cutout parabola. Another thing that you had to label would be the vertex. And the vertex is that point where it changes direction. It's coming down and then it goes back up again. We called it a vertex. Or we called it a minimum point here because it's the lowest that it goes. If you cut out the parabola and turn it upside down, that would be a maximum. The highest the parabola could go. So the vertex. So it's not just the lowest point, it's the lowest or highest, depending on whether it's facing upwards or facing downwards. All right, here we go. Example 1 says that we are going to graph 2x squared, and we're going to compare it with the parent function of y equals x squared. I'm going to start with y equals x squared. And then I'm going to do y equals 2x squared. I'm going to pick some easy values for my x, and I'd like to be on both sides of 0. So I'm going to say -2, -1, 0, 1, and 2. I'm substituting those x values into my function. And so I'm substituting them in right here. I'm only going to write the first one, and then I know we can do the number crunching after that. So this would say y equals, my x is -2, and it's being squared. It's important that it's in parentheses because the -2, all of it needs to be squared. That is a common mistake that you'll hear me say again during this chapter. When students are doing number crunching, they don't always put the negative number in the parentheses to be squared. -2 times -2 is 4. So I'm only writing out that first one because I can just put my numbers after that. When x is -2, I found that y was 4. When x was -2, I just found that the y value was 4. When x is -1, -1 squared is 1. When x is -1, I found that y was 1. When x is 0, it says that y equals 0 squared. 0 squared is 0. When x is 1, we get that y equals 1 squared, which is 1. And then 2 squared is 4. When x is 2, we found that y was 4. And so I'm going to draw this. It's rounded. It is not a point that it comes to. That's another function. So make sure when you're sketching these that you have a rounded place. And I'm going to label next to this that this is y equals x squared. I'm putting two graphs on the same graph, so I would label both of them. I'm going to switch my pen color. If anybody wants a red pen or a different color, they're up there in the cup. I'm switching the color to go to y equals 2x squared. For my second function, I'm substituting in the same x values when x is -2. Again, students will make mistakes on the order of operations that I should be doing right now. Students want to do 2 times -2 is -4 and then square that. That would be going out of order. Multiplying does not come before exponents. Exponents first. And so I would have 2 times -2 squared is 4, which gives me 8. And I can see that when x is -2, I'm going to get 8. And it's not on my graph, so I'm just going to keep going on here. So y equals 2 times -1 squared. I start with my exponents first. -1 squared is 1. So I get 2 times 1. So when x is -1, I get that y is 2. Zero squared is 0, and 2 times 0 is 0. When x is 0, I also got that y was 0. When x is 1, we get that 1 squared is 1 times 2 is 2. When x is 1, I get 2. At -2, let's see, at 6, 7, 8. I mean, I do like to have a kind of a guiding point to see where is it coming down. Where is it coming down? I can see right now that it's doing this. It's coming down to 0, and it's coming back up. I can see that it's on the inside of it. Does that mean it would be on the inside of it up here as well? And label it as y equals 2x squared. This is what your lab was really about. You kept comparing it to x squared to see what the parabola is doing. Okay, we're substituting in. When x is -2, what do we get? When x is -1, -1 squared is? When x is 0, 0 squared is? When x is 1, 1 squared is? And when x is 2, 2 squared is? Okay, I'm going to plot those points. I have some ordered pairs here, x, y, to plot. All right, squaring first. -2 squared is 4. So I'd have a -1/2 times 4 plus 3. What's half of 4? What's -1/2 of 4? -2 plus 3. Yes. Yes. But then you still have that negative out front with the half. So we have when x is -2, we got y was 1. -2, 1. All right, with the next one, substituting in -1. -1/2 times -1 squared plus 3. -1 squared is 1 times a half is a -1/2 plus 3. 3 minus a half? 2.5. What do we get with the next one? We're doing 0. So now we have y equals -1/2 times 0 squared plus 3. You're welcome. Okay, 0 squared is 0 times a half is 0. So we have 0 plus 3, which is 3. So we get 3, 0, 3. When x is 0, we get y is 3. Is it starting to make any more sense now? Yeah. All right. And now we get 1, y equals a negative half times 1 squared plus 3. Maybe you're starting to see that once I get one side of the parabola, the numbers are going to be the same on the other side, right? Because 1 squared is 1 times a half is a negative half again, and a negative half plus 3 is 2.5, which we can see here. Symmetry. So at 1, we also get 2.5. What do you expect to get at 2? Exactly. You're going to have that symmetry going on. And then I can sketch it. Okay, what we've got to do is compare. We haven't compared either one of our graphs yet. How would you compare y equals a negative half x squared plus 3 to the parent function y equals x squared? How would you compare them? What could you say about them? So compare the first with the second. So you could say that, yes, that it's facing downwards. Or facing down. Facing downwards. We're comparing it to the parent function of y equals x squared. Good. Different vertex. That would be the better way to do it, but we really haven't talked about that, so I didn't want to use language that's coming up in the very next part. So that's true. If you wanted to put one is facing in the positive direction and one is facing in the negative direction, that's what's coming up right underneath this. Don't forget to label each of your graph. Y equals negative 1/2 x squared plus 3. Yes. Yep. They have a different width. This one is skinnier than the second one. But they both share the same axis of symmetry. Ooh, that's good. Different widths. Same axis of symmetry. And then we're going to go back and do that on the first one. What's the same? What's different on the first graph? Yes, not according to my picture, though. Okay, so we have the same vertex. Whoops. And that one is, the width is skinnier. Correct. Same vertex and AOS. Width is skinnier. Same vertex, same AOS. I think that's about it for that one. What? Yes, you could actually say something else about the both of them. Both facing in the positive direction. Nice thinking, though. Trying to think about it that way. All right, that's all that we can say about those two. The next part is talking about which way it's facing up. Is that this one? Let me see. I'm sorry, one more thing on this one. Parent function. I keep using the word parent function, but I don't think you knew what I was saying. The parent function is y equals x squared. That's called the parent function. It's at the origin. It doesn't have any shifts on it. It doesn't have any change in its width. What do you think the parent function of a linear function is? Y equals x. Okay, that would be a parent function for the linear. It's just the variable with the exponent. So y equals x for a linear function, y equals x squared for a quadratic function. All right. Okay, properties of the graph. So this is going to be part of your homework, being able to find that AOS. And so when A is greater than 0, here's A, it's the leading coefficient. When A is greater than 0, it's positive, therefore it's facing in the positive direction. When A is less than 0, we can see that it's going to be facing in the negative direction. The next thing to notice would be that, and this is what your lab was about, if I had a big number, it got skinnier. If I had a fraction, it got wider. So the opposite of what you're thinking. So the narrower the graph, then A is greater than 1. Narrow, then A is greater than 1. Wider, if it is less than 1. So which one's wider? 10 or 1/10? 1/10 is wider. The smaller the A value is, the wider it's going to be. All right, this part is part of your homework. This is how you find the axis of symmetry. It's a formula that you're going to use, and it is x equals negative b divided by 2a. Here's your standard equation where you're getting all your a's, b's, and c's from. So the axis of symmetry and the vertex, the x coordinate of the vertex is also going to be negative b over 2a. So once I find the AOS, I use it with my vertex. And you'll see in the next example how all of this works. The last thing would be the same thing as when you have a linear function. A linear function, you can always tell what the y-intercept is. When it's in y equals mx plus b, when it's in slope-intercept form, you can always see the y-intercept. The same is going to be true of a quadratic. I can always see the y-intercept, and I'm looking at C. The y-intercept is C. Whoops. The y-intercept is C. So when I let x equal 0, it tells me what the y-intercept is. That's how we always find y-intercepts, even now, every time. Under the x-intercept, I let y equal 0. If I want to know the y-intercept, I let x equal 0. Okay, let's put this all together. What? I see that A is 2. B, what's B? Negative 8. You got to keep your signs in front of it. And C is 6. Once I can identify all three of those values, I can use them moving forward. We're going to start with finding the axis of symmetry. You do this the same every time. The axis of symmetry is going to be, here's our equation, x equals negative b over 2a. So x equals, the negative stays in there. Oh, hello. No, C is C. Thank you, Moffat. Okay, so we're just using the formula x equals b is negative 8. And then we have 2 times a, which is 2. So you got to watch out for this first negative. It's not part of the b. It's part of the formula. And then you just clean it up. We have x equals negative 8 divided by 4. And so our final is x equals a negative times a negative, which is positive 2. That is the axis of symmetry. And so I go to my graph, and I'm going to draw that line, because that symmetry is going to help me not have to do a lot of work all the time. It says to label it in the homework. That means label that. That's a vertical line, x equals 2. You label it on the graph, not on the side. Everything gets labeled on the graph. There's my vertical line, my axis of symmetry. You don't put AOS on it. I label what the picture is, and it's a vertical line. And the equation of a vertical line is equals 2. Now, the good news about that is my vertex is going to land on here somewheres. Okay, so I already know that the x value is going to be 2. It has to land on here because it's an axis of symmetry that cuts my parabola in half. So that means that right now, I already know that I have 2. Whoops. Negative b over 2a. My vertex is going to be at x equals 2. What do you think this next notation is trying to tell you? Exactly. I have a function, which is the one we're working with. If I substitute in my negative b over 2a into the function, it's going to tell me what the y value is. So that's what we're going to do. We're going to do f of 2. F of x is 2x squared minus 8x plus 6. That's the function. And I'm going to substitute in 2 for my x. When I substitute in 2, it's going to tell me what the y value is. Once we simplify that, we'll have our y value. So what do we get? 2 squared is 4, and 4 times 2 is negative 8 times 2 is negative 16. We have a plus 6. So f of 2 equals negative 2. 8 minus 16 is negative 8 plus 6 is negative 2. So we know our vertex is at negative 2. I substituted in the 2. I found out that y was negative 2. So I go to 2, negative 2. And I put my vertex. 2, negative 2. There's my vertex. All I need is one more point on either side. If I know where that point is, if the point's here, then I know it's going to be exactly the same distance on the other side, and I can draw the U shape. So all I need is one point. The best point, next point to get is going to be the y-intercept, doing f of 0. So f of 0, and again, you're not going to do this every time, but it's important to know what you're doing right now. F of 0 means I'm substituting in 0. So we get 2 times 0 squared minus 8 times 0 plus 6. What's 0 squared? Times 2. 0. What's negative 8 times 0? 0. What's your final answer? So most of the time what you're going to do is you're looking at your function. You're like, hey, when I substitute in 0, this goes away. This goes away. My c value will always be the y-intercept. So I get 6. F of 0 equals 6. That means that when x is 0, my y-intercept is at 6. When x is 0, y is 6. Step 5 says to use symmetry now. Use the symmetry. I see that I am 2 units away on the left. That means that I will be 2 units away on the right. And now I can clearly see that parabola. And I'm going to draw. That's how you graph then. Follow these steps every time and you'll be golden on graphing. The next example says, tell whether the function has a minimum value or a maximum value. Then find the minimum or maximum value. So from the last example, which steps am I going to use to start finding that minimum or maximum value? Can I tell if it's going to be a max or min right now? By looking at the function, can you tell if it has a maximum or minimum? Okay, Alexander, you're saying yes. Tell me what you're thinking.
If it's the negative, would it be a maximum? And if it's a positive, would it be minimum?
And when you say if it's a positive or negative, what exactly are you talking? Where are you looking to see that?
The 3x squared.
Okay, so he's looking at his a equals 3. His a equals 3. So which way is it facing? Upwards or downwards? It's facing upwards because a is positive. So does that make the vertex a maximum or minimum? It's the lowest it can go. That's the low. The vertex is the lowest it can go. So that's going to be a minimum value. All right, we answered part of the question. We know it's going to be a minimum. Now we actually have to find the minimum. How would I start to find the minimum? Exactly. You're going to do steps 2 and 3 every time. Step 2 gives you the X value, which happens to be the AOS, and step 3 finishes the vertex. So we're going to start with X equals negative B over 2A. I do just put the negative in the numerator. You can put it wherever you want. We already know that A is 3. What's B? Exactly. And like I said, not everybody is always going to follow every single step. I'm going to write them down only because these are notes. But like I said, I know you guys are not going to do this every time. Xander said, isn't it going to be just a positive 18? And you can see by how I'm substituting it in, that's true. So here's my negative B, negative, and here's my B value. And then 2 times A. A is 3. Simplify. What do you get? So that was the AOS that we don't really need. And then the vertex is what we're after. We know that 3 is going to be part of the vertex because the vertex has to land on the axis of symmetry. So we've already got half the vertex right now. We know that X is 3. How do I find the Y value? We need to substitute 3 into the function. We're going to substitute 3 into the function. And so we would have 3 times the functions up top. Right here is where I'm substituting that into. 3 times 3 squared minus 18 times 3 plus 20. Three squared is 9. And 9 times 3 is 27. And then we have 4, carry the 2 is going to be 54. You guys get negative 7? 27 and 20 is 47, and then 47 to 54. So when I substitute in 3, I get negative 7. This is my first answer. This is my second answer. The money that I want to make, the revenue. What's the revenue based on? What is the money that I'm making based on? It's based on, that's right, the attendance and I would say the money, like how much you're charging. So revenue is going to equal the money that you're making, and you're going to multiply to that how many people are there. Just trying to get an idea of basic what's going on here. Now we have some pieces to substitute in here. Let's see, we have 380 races per week, and it charges $35 to race. So 380 races, $35 to race, 20 more racers. So 20 more racers, that has to go with 380 racers. And then $35, and it's talking about a dollar reduction. So the money would stay together. And so we're going to write an equation of like, the money is going to be $35 subtracting, is it just 1x? Yes, it is. $1. And then attendance is going to be 380, 20 more racers plus 20x. we don't know how many people are going to be there or how many races. So if there's only one, then it would just be 35 minus 1 times 380 plus 20. But what if there's 2 people or 100 people there? Okay, we just have to simplify this now. I'm going to use my calculator on this word problem. Let's see. Do you guys know how to multiply like this? So you do 35 times 380. It's like doing the distributed property 4 times. And then I do 35 times 20x. So 35 times 20 is going to be 700x. I'm all done multiplying with the 35. I'm going to move on to the negative x to multiply. Negative x times 380 is going to be negative 380x. And then negative x times 20x is going to be a negative 20. What's x times x? X squared. Okay, we just need to rearrange it so our x squared is first, and then our x's, and then our constant is at the end. So I have negative 20x squared. I need to combine these two together. These are both x's. 700 minus 380. It says maximizes. We're trying to maximize how much money we can make. That means, is my A positive or negative? Is my parabola facing upwards or downwards? That means I'm looking for this right here. I want to maximize my money. So you need to use the formula that's going to help me find this maximum. Look back at the previous example. We just found a minimum value. On example 4, I can use that same technique to find a maximum. Go ahead and find the maximum value, just like you did in example 4. Find the AOS and take that number and substitute it in. All right, so we need x equals negative b over 2a. So we get negative, and then b is 320 divided by 2 times a. And so we get negative 320 over negative 40. And we should get 8. So I already know that x is 8, and I'm looking for the y values. So I take the answer. Okay, I'm going to give you your homework. And I would use my calculator on this. I don't expect you to do number crunching like this. Okay, when it's a word problem, you can use your calculator. Let's talk about homework here. Your homework is 1.1, and it's going to be 2 through 22 evens. And that's it for us today once you get everything written down that you need. Yes. So I would just punch this in my calculator. I've got negative 20 parentheses 8 squared, and then plus 320 parentheses for 8 times 8 plus 13,300 equals, so when x is 8, I found that y was 14,580.